In this lesson, you'll learn how to use the index laws to simplify and maybe even solve some equations and expressions. In example 1a, we're looking to simplify the following. Our first step is to multiply our coefficients, the numbers out the front. So 2 times 3 is 6. Nice and straightforward there. If we have the same bases, so in this case a, we can add the powers if we're multiplying those two values. So a to the power 4 times a to the power 7, adding those powers gives us a to the power 11. Same thing for b, giving us b to the power 7. Of course, there is a 1 on this final b there. Here, if we have a power outside a bracket and powers or values inside the bracket, we need to multiply those powers. That leaves us with 2 to the power 5. Of course, this is really 2 to the power 1, m to the power 20, and n to the power 15. If you're asked to simplify with a basic numerical, you might need to work out what 2 to the power 5 is, but we're just going to leave it like that for the moment. In example 1b, our first step is to simplify 5 and 20, 5 going into 24 times. Then again, if we have the same bases, so in this case x's and y's, we can subtract any denominator powers from the numerator. So in this case, 6 minus 2 is 4, and 9 minus 3 is 6. That leaves us with the final solution of 4, x to the power 4, y to the power 6. Example 1d is completed for you. Again, it's just multiplying in an external power from brackets inside the brackets, and there's no simplification we can do from there. Example 2a and b, looking at the zero power law. What this states is anything to the power 0 is 1. In this case, it would just be m to the power 0, meaning that we get 5 times 1, which is 5, plus 4, finishing with 9. Here, x to the power 0 is our 1, so that gives us 12. And because all of this is to the power 0, all of this becomes 1. Minus 2 times 1 is just minus 2, which gives us 10 as a final solution. Example 3a, getting a little bit trickier here. First step is to multiply or get rid of our brackets, so multiplying in those powers, giving us 4 squared f to the power 4 g squared times f squared g all over 3 f to the power 3 g to the power 6. We probably want to simplify this to just 16. It might be easier to work with. There's nothing we can really do with those numbers there anyway. Our next step is to combine our numerators, so I'm just going to do that in another line of working. So that was using index law 1 to add our powers along our numerator values. And now we can start cancelling. So f to the power 3 is a denominator. Subtracting 3 here gives us f to the power 3. And we can actually do the same thing. So g to the power 3 as a numerator, I can subtract it from here, giving us g to the power 3, just keeping in mind that that is staying as a denominator value. So 16 f to the power 3 over 3 g to the power 3. Let's do one more of those. I'm going to write out the full solution for part B, and we'll go through it. So in example B here, our first step is to expand all these brackets, multiplying in our powers. In this case, all of this is going to become 1, leaving us with 3 as the denominator. We get as the numerator 2 squared m to the power 6, and 6 squared n to the power 10. Denominator here, negative 2 to the power 3, n to the power 3, and m to the power 4. I've then just expanded my numbers just so I can work with them a bit better on this next line, or worked out those powers. 3 and 36 cancel with a 12 here, 4 and 8 with a 2, and then the 2 with the 12 becoming 6, so that's just simplifying as we go around our numerators and denominators. M to the power 4, we're going to subtract that 4 from our numerator m, giving us 2, and n to the power 3, giving us n to the power 7. That leaves us with this negative kind of coming out the front as negative 6m squared times n to the power 7. It's going through quite a few index laws. Give some practice to that. Be careful with these negatives. So negative 2 to the power 3 stays as a negative, but if that's an even power, it does become a positive result. So just be careful with the way you work through those different problems.